So I'm Andrea. I'm from Hofstra University's Office of Admission, and I'm not a computer engineer, but I know that you are interested in learning about this particular field, and I will do my best to share what I have learned about computer engineering. And I've entitled this presentation Computer Engineering 101. And I'm just going to give you some basic information. And of course, if there are any questions that come up, I'll do my best to answer them, but most likely I'll be able to put you in touch with one of our faculty members. As an admission counselor at Hofstra University, I represent a school in your hometown, close by, right down the block. And I can certainly talk to you about college-related information, anything you might want to know, generally speaking, about the future after high school. But for tonight, I'm going to focus the material that I have to share on the specifics of computer engineering. And so our agenda is basically to define computer engineering, talk about the profession itself and what do computer engineers do, talk to you a little bit about the academic curriculum that students who choose a profession in computer engineering specifically have to take, but I'll broaden that a little bit to talk about engineering disciplines in general. The earning potential, can make a lot of money being an engineer, specifically being a computer engineer, and we'll talk a little bit about the future in the job market. I do have a cute video that really illustrates a lot of the things that I'm going to share, and we'll do a little Q&A. This is a personal session between myself and the one patron of the library in Levittown and our friendly librarian who's joining and recording for the public. So thank you all for your kind attention and for allowing me into your home and into your life tonight to learn more. So what do you think this person is doing? I can see that this computer engineer is working on a central processing unit and is, looking at wiring, and electrical wiring comes into play in computer engineering because computer engineering is a combination of hardware and software and network engineering. So there's a lot of electrical components to it. There's some business components to it, information technology, and computer science. And when I think about computer engineering, even before I knew really what this was all about, as I was preparing for the presentation, I was thinking, gosh, we all have devices. We have probably multiple devices in our homes, right? Phones, computers, and, radios and televisions. And there's a lot of engineering that goes into the development and the maintenance of these devices. And when I think about some of the gaming that I enjoy, like I love Candy Crush and all the colors and all the sounds. And then I think to myself, wow, an engineer had to write the code to make that app work. And any other gaming app, right? I mean, there are village games where you're in a village and you're fighting off armies. There are card games. There has to be a code and a design of code that allows that game to run any time of day on any device and to allow for interactive gaming. So this is not surprising why this profession is popular today. We all have devices. We all need our devices. I think we're a little more dependent on them than we maybe should be. And we utilize them so much of the time. And yet they are running on the impact that a computer engineer would have. Electrical engineering plus computer science equals the development of new technologies. And so when you think about the latest model, the latest computer, the latest phone, the latest device, the faster device, the fastest, the impact that the computer engineers and engineers in general are having to make our lives easier, to make things run faster, to make things run smoother, to allow for this, this presentation to appear on your screen. That's engineering. And I've heard faculty, a chemical engineer once said, engineering is what people do to make other people's lives easier. So when we think about when we dispense shampoo and conditioner, That's designed by an engineer, the dispensation of those things, and how different, a pump of soap is in comparison with a tube of mascara, for example. That's engineering, right? The size, the shape, and the way that it is dispensed, the amount, and the way in which it's dispensed, and the way it keeps the liquid inside, and the way that it keeps on a shelf life. That's engineering. And then when you think about prosthetics or any kind of devices that make human life easier, respirators, prosthetic arms, prosthetic legs, these are things that are making lives easier. And so that's engineering in a nutshell. And I've given you a little bit of a smattering of different disciplines. Of course, we're focusing on computer engineering and the maintenance and integration of hardware and software. Okay, and we'll talk about that, designing, building. And I ask you, because I know a lot of high school students who have told me and have written their essays about it for admission, about the time that they chose to build a computer and what it took to build a computer, and how when they finally pushed that button and after all that hard work, voila, it was working. And so the hardware and the software and the design and the building and the maintenance of it. And it takes a lot of skill and it takes a lot of knowledge. The hardware, you see pictures here, the hard disk, the printer, the keyboard, the mouse, the memory, and the central processing unit. I remember when I think the central processing unit was called the motherboard. I'm not sure if that's no longer a term that's used, but I remember when I had a big computer, and they've gotten smaller and more lightweight. I'm talking to you from a laptop right now. And with the ability to have my camera on and be talking to you, we have a new arrival joining. So just in time, hello there. You're learning now about the types of computer hardware. So computer engineers are designing and maintaining systems of hardware. Hello there. And the software. So when you think of all the different apps that are running, Microsoft PowerPoint. This presentation is run by PowerPoint, and I had, a template to work from. Why? Because that's loaded onto my computer. And I've got 3 screens. I actually had to disconnect my laptop from my desktop so that you wouldn't see the future of the presentation, all the next slides, because I'm talking to you from the laptop with the camera. So computers and computer designs are changing and always changing. I don't know if you would recall commercials over the years where they would say, oh, there's an app for that. There's pretty much an app for everything, right? You have your Microsoft Word that'll allow you to get a blank document, and you could write a paper, a research paper. You could write an essay. You could write a letter. You've got Google Chrome. You could probably all know what all these logos are for, but I don't know them all. I know the Apple one. Haha. I was born in the 70s, so I am learning every day from young people and how quickly young people have adapted to changes in technology. And so this field, engineering in general, and anything technological, anything STEM related, has grown, and the income potential is strong. And the interest in this profession is growing. There was a time where I, working at Hofstra University admissions, was talking to mostly students who were interested in the humanities and the social sciences and the fields of business and teaching and media. And over the last 10 to 12 years, I have noticed a very strong increase in the number of students who are interested in the STEM professions, computer science and engineering, as well as the health professions. And the reason for that is, as technology grows, so does the demand for good technology professionals. As the need for strong and better healthcare increases, so does the need for high quality healthcare professionals. But in addition to those reasons, I think a lot of young people are afraid that other professions will not have jobs. And that is the big fear of young people, especially as they invest in their education to the tune of $50,000 or more. They're going to live on a campus. Now they have to think, okay, how can I make sure that I'm in a profession that's going to allow me to support myself and live comfortably and have a guarantee that there is a job for me out there. So computer engineering, the job potential is growing, and I'll show you a little bit of salaries. If you want to type into the chat feature and say how much you think the earnings are, I would love to hear what you think is the salary per year of an engineer, and we'll see if you're right in a little while. Okay, so examples of software: Microsoft Windows, Excel spreadsheets, being able to organize things on a spreadsheet, right? Gmail, all that stuff. Those are the software. And a computer needs to have the hardware and the software. I need to have a keyboard. I may need to have a mouse, right, where I could click around and utilize my cursor. I need to have a memory, otherwise I can never save a presentation. I need to have those things, but I also need to have those apps so I can do functions, I can do work, I can utilize systems. Okay, so the essential skills to develop are in math, science, and engineering. We'll talk a little bit about what exactly the curriculum looks like in computer engineering. Data analysis and interpretation, the ability to problem solve, the ability to design a system that works, and to continue to improve upon previous designs. So thinking outside the box, working within a team, solving complex problems. And I have a great video that I'm going to show you that really highlights these kinds of things and the kinds of out-of-the-box thinking and problem-solving skills that are needed. Now, I was a psychology major in college, and I learned all about theory of psychology and practice of counseling, and all of that is great knowledge. And I didn't have to take that much math and science to get through that. But an engineer and a computer science major is definitely going to have to learn a lot more advanced subjects in the STEM fields: science, technology, engineering, and mathematics. So what are these courses? Physics, yep. Chemistry, calculus, algebra, probability and statistics, differential equations. And of course, you can look up these kinds of things online and get the definition and the types of courses, that the kinds of math. Because if you're not sure what these things are, you might want to see, well, what kind of math is that? And some of it is taught at high schools, but not everything. Okay. And in college, subjects that you took in high school are going to go a lot faster in college semester. So it definitely behooves you to take these kinds of subjects in high school as much as you can, so that when you get to college, you will have the framework that you need to move forward, because you're going to need to take calculus through level 3 in college. And I know that you don't get all that far in high school calculus. So having a basic knowledge will help you tremendously. Circuit engineering, electrical engineering, because remember, there's a lot of wires, right? If you take something apart and you see red wires and yellow wires and white wires, maybe sometimes there's blue wires and things. I'm trying to think if I've ever taken anything apart. Probably not, because I don't know how to put it back together. But a lot of young people who end up being engineers, a lot of times they started out enjoying building things with Legos or taking apart things that work, mechanical things that work, and look for how they work. I've known young people who have taken apart clocks and televisions and DVRs and all kinds of things, radios, just to see how they work and tinker around and see, okay, how does this work? Where is the life in this clock? Where is that ticking coming from? How can I make a better design, right? Because as you know, clocks have changed their look, their function, their design. Okay, so anything you do to make life easier for people is engineering. Electromagnetics, now we're getting into topics that I can't define for you. Computer science, mechanics, software engineering, microprocessing systems, data structures and design, algorithms and programming. I might not be qualified to give this presentation right now because I don't have this background, but I've learned for you what this is going to take. And since I didn't see anything in the chat, I might as well tell you that job growth is expected to rise by 20% by 2026, which means that there's a lot of engineers that are going to be sought after, and they're going to make a lot of money. They're going to make over $100,000. 110 is the minimum here for a software engineer. Hardware engineers make even more. And network engineers are a cross between business and technologists. So there's a lot to it. This is a profession that, if you think about it, why do people make a lot of money in a profession? It's because they have a skill that other people, the average person, does not possess. Okay. And I think back to working at a college. There are students who work in every office on our campus, but a lot of them make minimum wage, right? It's the lifeguards and the computer technicians who make the bigger salaries, even as students. Why? Because not everybody has the certifications that it takes to be a lifeguard. They need to have certain skills. They need to know CPR. They need to know certain things that the average person doesn't need to know. I never took a class in first aid. I don't have a credential for life-saving techniques, so I can't be a lifeguard. So therefore, I don't have that skill set, and therefore I can't do that job. Well, the same thing is true for computer engineers or any engineers and computer scientists. I can't create a new phone. I can't come up with a new design or a new function. I like my iPhone just the way it is, right? In the olden days, before cars were developed, I would have been one of the people that would have thought, could we get faster horses? As opposed to, let's build a car that'll get us there faster. So thankfully, Ford and all those other, pioneers designed and created cars, because I would have been looking for a faster horse to get me where I was going, right? And that's the difference between an average person who thinks, okay, well, I like my phone just the way it is. I like my apps just the way they are. I'm not thinking of what the iPhone 20 is going to look like. I'm just happy I have the 12. And when I had the 6, I had that for a very long time too. And everybody was like, you still have the 6? Okay, so the engineers are the ones that have the vision for the future, and they're earning great salaries. So I have a video I want to play for you, but I'm going to show you my contact information first. So you can take a picture with your phone. I'm going to put my contact info in the chat. But this video that I have is really, really great. And it taught me some cool stuff that I didn't necessarily think of before. So I want to play this video for you now.
Computer engineering is the combination of electrical engineering and computer science. As in, if you have the electrical engineering curriculum and the computer science curriculum, which don't share really any classes, the computer engineering curriculum is literally 50% of the EE classes and 50% of the CSC classes. Now this only accounts for your core major classes. It does not include the elective classes in your last years, where you can choose from a long list of computer engineering, computer science, or electrical engineering classes to specialize in that I'll show you at the end. But let's dive into specifically what classes you take, which you already know if you've seen the computer science and electrical engineering videos. On the electrical engineering side, you'll have to take all their basic circuit classes, where you learn resistor, capacitor, and inductor circuits. You will solve for the voltage and current moving throughout them, and these are the simpler circuits, but are the techniques and components that are a foundation for circuits that exist everywhere, like in phones, computers, satellites, drones, etc. You will learn about the basics of binary and how computers make decisions using ones and zeros. This includes learning things like logic gates. These take in ones and zeros and produce a certain output based on the inputs. Each different gate does something different based on those inputs. Computers have hundreds of millions of those, and when strung together can do very advanced digital processing, such as for a digital lock, a wristwatch, an alarm system, etc. You'll also take one of their signal processing courses, where you look at complicated signals or changing voltages in time and analyze them in detail. This is important in things like filter design and removing unwanted signals. Just like your radio in your car is being hit by every radio station in your city at once. So why do you only hear one at a time? while your electronics within process the signals and filter or remove everything except the one you're listening to. So when you tune to, let's say, 94.5 FM, your car is allowing signals of 94.5 megahertz to pass to your speaker, but filtering out everything else so you only hear that station. So you'd analyze the math behind the manipulation of these signals and see how to determine which frequencies they are made up of. This is essentially a math class and involves a good amount of calculus. If high-level math and this class seem interesting, then electrical engineering may be better for you. Although computer engineers do have to take multiple years of calculus and apply it in some other of the electrical engineering classes as well, so hopefully you enjoy math somewhat before entering this major. Now, the computer science classes you take don't involve high-level math, so computer engineering is kind of a happy medium and is not as math-intensive as electrical engineering in undergrad. Then lastly, you'll take half of their electronics courses. This is where you look at the transistor and diode. A transistor has the ability to switch between a high and low voltage, like 5 and 0 volts, and computers read these as ones and zeros. So that's what we actually mean when we say a computer reads ones and zeros. There are over 1 billion transistors in your laptop to make it work and store all the data. So you'll do circuit analysis, but now with the knowledge of how transistors work, which are way different than a simple resistor, but apply the same principles like looking at voltage in a loop and conservation of current you may have seen in high school physics. In the lab, you'll hook up circuits on a breadboard. These are where circuits go for basic testing, then once everything seems to work, that's when you would move it to a circuit board that you've probably seen in computers and phones. How you test them is by using an oscilloscope, which is where you literally see the electric signal or changing voltage in time. So you'll see maybe if the voltage in a transistor is changing between a high and low one, or as a computer would see them, a 1 or a 0. This is all the hardware, the electronics, the circuits, the breadboard, etc. that computer engineers need to learn. But now let's get into the software or the computer science side. You'll start to learn the basics of programming in C and Java. C and Java are programming languages that have their own syntax and rules you have to follow that tell the computer what to do. These are the languages that Google, Facebook, LinkedIn, etc. all use to make their websites work. These are not the languages to make the layout of the page or to make it look pretty. That's HTML and CSS. These programming languages are the backbone of the websites. Like, how does Google search their database and bring up the results quickly, efficiently, and with the best results first to help you find what you're looking for? Or how can Pandora guess songs you'll like based on what you've listened to or rated and so on? These are what programming languages accomplish. Programming is what makes apps, video games, and even instructs things like unmanned aircrafts and satellites. But you'll start from the very beginning if you've never coded before. So in your first class, you might be asked to write a program where a user can type in 2 numbers and it outputs the.
So, you want to become a software engineer? Stop following coding tutorials. Start with CodeSmith.
The sum. Or they input a list of numbers and it outputs the largest. Or they input a word and it outputs that word backwards. By the end of it, you may be asked to program something like a very basic blackjack game. You'll also get into some basic algorithms, which are kind of like step-by-step instructions to solve a problem, just like this image even. But in programming, you'll be asked things like, how do you tell the computer to put a list of numbers in order as efficiently as possible? Or how does the computer search if a number is in a list? So you gotta understand what the computer can do. This may be easy for us to do using our brain, but computers are not free thinking. They need exact step-by-step instruction to do what you need them to. As a quick example, if you had a list of numbers in order and the computer had to check if the number 26 is there, well, you could tell the computer start with the left, check each one until you find 26 or run out of numbers, which is probably what you did in your head very fast just now, but that takes 9 checks. So what if instead we have our list and we took the middle number and 26 is bigger, so we threw out everything else less than or equal to that middle number. Then with the new list we did the same thing. Check the middle number and look, we already find 26. And even if it weren't in the middle in this check, this is still way often less steps than the previous, and therefore it's more efficient than checking each one by one. This is one kind of searching algorithm and is the kind of thinking you'll need for programming. Programming mostly doesn't involve high-level math. You won't see calculus in basically any undergrad computer science classes, but you do need to problem solve and have the ability to analyze these using simple math, but in a clever way that the computer can understand and follow. And note, I just showed you how the algorithm worked. In the class, you'd also have to program it using knowledge of the languages. Lastly, one of students' favorite classes is where you learn about the Arduino. This is finally where hardware and circuitry meets programming, and you'll take with electrical engineers. The Arduino has lots of inputs for you to hook up wires from an external circuit. As in, they basically read in voltages, then you program what you want it to do based on those inputs, where you plug in and download the code onto the Arduino, then use it for different purposes. So maybe you use a position sensor connected to a circuit and then connect that to the Arduino. The Arduino reads in voltages, which may be higher or lower depending on if an object is close or far, then program the Arduino to output voltages, which it can do as well, when an object is close, that spin the wheels of a robotic vehicle to avoid that obstacle, and thus you have collision avoidance. Overall, computer engineering is great because you have skill on the programming and software side as well as the hardware and circuitry side. So if you wanted a job at maybe Apple, you could work on their software, operating system, or iOS, the system memory, the servers, or with their encryption and security. Or you can help with their electronics and hardware. You can work at defense companies on something like obstacle avoidance for UAVs, or create a computer simulation for an aircraft and radar system to see how it will work in theory before designing it. Probably hard to get that kind of job right out of school, but you can see how your future career has a lot of potential. On top of being a mix of electrical engineering and computer science, you will take electives where you can choose from any of the upper division computer engineering, electrical engineering, or computer science classes. Some may include computer security and learning about firewalls and access control, computer vision and looking at image processing of 2D and 3D images on the computer like facial recognition software, autonomous robot navigation and programming vehicles to move around automatically, web development and interactive website design, and of course, so much more.
So there's a lot that you can do in this profession. You're going to learn so many different things and so many different avenues in the career itself. So whether it's programming music, game design, database management, language processing, artificial intelligence, computer graphics. Our computer science students learn in a class called ethical hacking. They learn how to defend and hack into systems. So there's a lot of different types of classes that you're going to take in order to prepare yourself. But the most important thing that I took away from learning this is that computer engineers are really a merge between the business world, the computer science world, and the engineering world. So they have a lot of different functions and a lot of different capacities. And when students are in school, college in particular, at the undergraduate level, it's very important that you gain field work experience and maybe even take a co-op if you can, if the school you're going to offers it, where you have an opportunity to work in your industry for 6 to 8 months and actually earn an industry salary and work under the supervision and mentorship of a company's engineers or computer scientists, whichever discipline you choose. And you will then have the opportunity to gain real world knowledge while you're still in school before you've even completed your undergraduate degree. So that is my presentation for the evening. I hope that you gained some greater knowledge than you had before. I certainly did in preparing it, and I hope that you have a wonderful journey. Are there any questions that you have for me at this time?
I was wondering, what's the minimum score for AP classes for the computer engineering program?
Okay, great question. So it depends on the college or university that you're applying to, but I will say from my experience at Hofstra that for many colleges, if you earn an AP score of 3, 4, or 5, many colleges will accept the credit, accept the score and give you credit for those courses. Some colleges will only accept a 4 or a 5, and some might give credit some of the time to some subjects in which a 3 is earned, but not 100% of the time. So you're going to want to ask every single school on your list And when you develop a college list of schools that you're interested in, that you are interested in applying to, you'd want to go to their website and find out. And if it's Hofstra, for example, I'll type into the chat how you can find out about our AP credit policy. It's hofstra.edu/AP credit. And you'll get our whole policy on how we transfer credits. For the most part at Hofstra, it's 4s and 5s with some exceptions where a 3 is allowable. But in most cases, it would have to be a 4 or a 5. Other colleges are more lenient, so that depends. But it's never below a 3 that you would be earning credit. It would always have to be at least a 3, with, in most cases, 4s and 5s being more accommodating. Great question. Are there other questions? It was a pleasure meeting you, and I wish you all the best on your journey through your education, where you are right now, and into your career pathways. And